Students, today we are going to discuss about electromagnetic waves chapter. So, first of all, how the electromagnetic waves are produced. Electromagnetic waves, EM waves, are produced. EM waves are produced by the accelerating charges. By the accelerating charges. This is very important point. When the charge is accelerated, it produces time-varying magnetic field, which in turn produce time-varying electric field. These two mutually perpendicular electric field and magnetic field will combine together and form electromagnetic wave. So the electric and magnetic field vibrations are perpendicular to the direction of propagation of wave. This is the direction of propagation of wave. So the electric vibrations and magnetic vibrations are perpendicular to the direction of propagation of a wave. Okay. So the electric field Ex along x direction, the electric field component, the electric field component along x direction, it is indicated by Ex is equal to E naught sin kz minus omega t. Similarly, the magnetic field By along y direction is indicated by By is equal to B naught sin kz minus omega t. So these are the equations represented electric field and magnetic field along x and y directions. So here this is the maximum electric field and this is the maximum magnetic field. So the ratio of E naught and B naught is called velocity of light. So the ratio of maximum electric field to maximum magnetic field, that is equal to C is equal to E naught by B naught. Now we are going to discuss about some important characteristics of the electromagnetic waves. Characteristics of EM waves. Some important characteristics of the EM waves. So, the speed of electromagnetic wave, number one, the speed of EM wave. The speed of EM wave in vacuum. C is equal to 1 by square root of mu naught epsilon naught. This is the first property. And also the speed of EM wave in medium. The speed of EM wave in a medium. In a medium, C is equal to 1 by square root of mu epsilon, where mu is the permeability of the medium and epsilon is the permittivity of the medium. And these are travel with velocity of light. They travel with velocity of light, and also they are transverse each other. Their nature is transverse nature. EM waves are transverse nature. Why? This is the propagation of EM wave. The electric field vibrations and magnetic field vibrations are perpendicular to the propagation of wave. So we can say these EM waves are transverse in nature. Okay, and also they do not require any medium. They do not require any medium to propagate. Any medium to propagate. So this is an important, and also they are not deflected. They are not deflected. They are not deflected in electric field and magnetic field. Why? Because they have no charge. They have no charge. And also these electromagnetic waves, they carry energy and momentum. They carry energy and momentum. When they travel from one place to another place, they carry energy and momentum. So these are the characteristics of the electromagnetic waves. These are the very, very important characteristics. Now we are going to discuss about various types of electromagnetic waves. So electromagnetic waves are classified according to their frequency or wavelength. So that is called electromagnetic spectrum. Electromagnetic spectrum. Now we are going to discuss about different types of electromagnetic waves and their important properties. Now we are going to discuss first, number one, radio waves. Radio waves. Number one is nothing but radio waves. So radio waves having high wavelength, and they are produced by accelerating charges. They are produced by accelerating charges. Accelerating charges. And they are used in radio and TV communication systems, and cell phones used radio waves to transmit voice communication in UHF band. So they are used in radio and TV communication system. TV communication system. And also cell phones, they are used in cell phones also. So cell phone communication system also belongs to radio waves. So they have a high wavelength. Okay. Now we are going to discuss another electromagnetic waves, that those are nothing but microwaves. Microwaves. So these microwaves have a short wavelength. So these are nothing but short wavelength radios. Short wavelength radio waves. Short wavelength radio waves. And these are produced by special vacuum tubes are called. They are produced by special vacuum tubes. Those are called clystrons and magnetrons and gun diodes. These are the sources for microwaves: clystrons, magnetrons, and gun diodes. And these are used in radar communication. Radar communication. And they have short wavelength. Due to that, they penetrate at obstacles also. So these are used radar communication to guide aeroplanes, aircraft navigation to guide aeroplanes, aeroplanes. And also these microwaves are used to find out speed of tennis balls, cricket balls, and speed of vehicles also. Speed of vehicles. They are used to find speed of vehicles. Speed of vehicles. So these microwaves also used to determine the speed of tennis balls and cricket balls and the speed of vehicles. And also microwaves are also used in microwaves are also used in micro ovens to cook food. By using these microwaves, we can cook food in micro ovens. So these are the important properties of these nothing but microwaves. Now we are going to discuss about infrared waves. Infrared waves. Now we are going to discuss about what? Infrared waves. So these are produced by hot bodies and molecules. How they are produced? They are produced. They are produced by hot bodies and molecules. Molecules. So infrared waves are produced by hot bodies and molecules. Okay. These are also referred as heat waves. They also referred as heat waves. Heat waves. This is because water molecules present in the most of the material absorb these infrared waves. After absorb, their thermal motion starts and they heat up and they heat the surroundings. That's why they are called heat waves. So another important application is infrared lamps. Infrared lamps are used in physiotherapy, physical therapy. So infrared lamps are used in physical therapy, and also this infrared radiation also play important role. Already we know that in first year. Also play an important role in maintaining the earth temperature warm, in keeping the earth warm, in maintain the earth temperature warm. So because of that infrared radiation, the earth temperature is in warm. So without infrared waves, the earth temperature would be minus 10 degrees centigrade. Okay, because of this infrared radiation, they keep the earth in warm position. And also infrared detectors are also used in earth satellites. Infrared detectors also used in earth satellites. Used in earth satellites, both for military purpose and multi-purpose to observe growth, growth, growth of the crops, growth of the crops. So these infrared waves are also used in camera flashlight to take photos in fog time, and also infrared waves, infrared waves, infrared infrared waves also used in also used in also used in remote switches, also used in remote switches, remote switches, remote switches, remote switches in a household electronic system, in household electronic system, in household electronic systems. In a household, that means in TV remote and video recorder remote, this type of remotes, these infrared waves also used. Not only these remotes, but also to take a photo in fog condition, we use these infrared waves in flashlights also. Okay. And also the very important point is, you have to remember, snakes can detect infrared waves. Infrared waves. We are unable to detect infrared waves. Our eye is not sensible to infrared waves. Our eye only visible to only VGR region. But snakes can detect infrared waves. This question asked in last year examination, public examination. So please note this important point. Okay. Now we are going to discuss another kind of electromagnetic waves, that is visible rays. Visible rays. Visible rays. So in electromagnetic spectrum, our eye is sensation to these visible rays. Okay. This wavelength range is nothing but 700 nanometers to 400 nanometers. Okay, 700 nanometers to 400 nanometers. Now we are going to discuss UV rays. UV rays. So these are produced by extremely hot bodies. Extremely hot bodies. These are produced by extremely hot bodies. Extremely hot bodies means the only source is sun. Sun is source of UV rays. Sun is source of UV rays. Sun is source of UV rays. So from sun we receive UV rays on the earth. When a body is exposed to, when a body is exposed to UV rays or UV radiation, it induces production of more melanin. Melanin is a one type of acid. Because of that, our hair is in black. So whenever a body is exposed to UV radiation, it induces the production of more melanin, due to which causes tanning of skin. Okay, so this is the bad experience with the UV rays. So we must take precautions that to escape from UV radiation. And also UV radiation UV radiation. UV radiation is easily absorbed by glass. This is very important. The glasses are easily absorbed UV radiation. The glasses are easily absorbed UV radiation. So that's why welder, welder he wear glasses or spectacles to protect their eyes from UV radiation. Okay. So whenever he wear the special spectacles or glasses, he can protect from UV radiation. And also very important point is UV radiation is also used in LASIK eye surgery. LASIK eye surgery. This is one kind of eye surgery to replace lenses or glasses. By using this laser therapy, we can do eye surgeries. So a person who is suffering with eye problems, for those people, UV radiation also used in LASIK eye surgery. So these are the important properties, important uses of UV radiation. Now we are going to discuss about X-rays. So here one more important electromagnetic wave, that is nothing but what? X-rays. So X-rays are produced. So X-rays are produced when high energy electrons are bombarded with target element, with a metal target. Whenever these high energy electrons are bombarded with a metal target, then they lose kinetic energy. That loss in kinetic energy appears as X-rays. Okay, their wavelengths are in the range of 10 to the power of minus 8 meters to 10 to the power of minus 13 meters. This is very important. X-rays wavelength ranges. And also X-rays are used as diagnostic tool in medicine. And also used to treat in the treatment of cancer. So these are some important uses of X-rays. Now we are going to discuss about gamma rays. These gamma rays are produced in nuclear reactions. So they are produced in nuclear reactions. and also they are used in they are used in they are used in medicine to destroy cancer cells, to destroy cancer cells. These are the applications of gamma rays. So these are the different types of electromagnetic waves. Now I arrange these electromagnetic waves in the order of decreasing wavelength. Decreasing wavelength. So in these all electromagnetic waves, which one has high wavelength? That is nothing but radio waves, has high wavelength. After that, microwaves. Microwaves. After that, infrared waves. Infrared waves. After that, visible rays. Visible rays. After that, UV rays. UV rays. And UV rays. Then X-rays. Finally, gamma rays have least wavelength. Gamma rays has a least wavelength, highest wavelength, radio waves, least wavelength, gamma rays. Gamma rays has a high energy. Gamma rays has a high energy, so that they have least wavelength. Okay, so this order is decreasing the wavelength order, decreasing wavelength order of the electromagnetic waves. So these are the important properties of electromagnetic waves. So the weightage of this chapter is 2 marks. So you have to read all the properties and properties of the electromagnetic waves. So this is about electromagnetic waves.